Okay, we are recording, and this is Durwood King with the ELC 117 Motors and Controls. This is Tuesday, January 26, 2021, and we're in the shop doing our live Zoom for the shop. And I'll be rolling the cart around from lab to lab, and I hope I can remember to put the camera where we are. So you'll see me moving. Yeah, everybody make sure you got a mask on and your gloves. And I'll start where we left off at, checking stuff, and we'll keep on checking. Okay. Everybody got a mask? Okay, make sure you keep it on, and safety glasses, and the tools are here. And let me know kind of where. Yeah, Brandon, we'll go ahead and check yours since that's where we're leaving off. Y'all, do y'all have something ready to check? You do. Everybody does. Okay, good. So just keep reminding me. Keep reminding me when you see me coming away from one. Throw your hand up. Remind me. Okay. Yeah. As a matter of fact, all this is fine from yesterday. You had your ground hooked up. Just got to tie that. That's right. Maybe be ready. Okay, so for whoever's watching recording, show you what this is on the three-phase start-stop circuit. And this is the diagram here. It's got the three-phase power going to the motor starter up top, and then you have your step-down transformer, start-stop push buttons, motor starter coil, holding contact, overload contact, and what's not shown here is the wiring for the motor, and that's shown actually on the nameplate. It shows you if you're going to go low voltage in the 230 range or high voltage in the 460, 480 range. So he's done it this way. It's already been verified down here from yesterday. You see yesterday's recording, you'll see that it was verified. When you come in person and do it, we will verify that what you have is correct.
Let's do it. This is the old transformer over there. Can I take it apart so I can see inside of it?
Yeah. Sure.
Just take these screws off?
Yeah. I don't know how far you get, but yeah, you're welcome to do it. Yeah. Right. You'll see a bunch of windings in there, big copper windings.
Which one are these?
Their numbers would be 1, 2, and 3. The numbers are up there. Well, they're not necessarily just number-wise. Just go off the numbers. So you coming here full time now?
Yeah. I was thinking about not coming this semester because of the stuff, but I was like, I'm already
I'm already started. I might as well.
Right. Yeah, just use your PPE and it's everything's a risk. Driving on the highway's a risk. I mean, you know what I'm saying?
Yeah, my mom got, well, my dad was driving, but my mom's car got into an accident yesterday.
Got an accident.
So everybody was all right.
That's good.
I had my son with him.
Uh-huh. Okay. I gave him a quick connect here with a power connection here. If we tie into a power drop from the ceiling, and we move this board to board. If he's tying this 1, 2, and 3, that's the 3-phase power coming in here and ground. He wired it from here on out. So he's got his start-stop button here and the starter, and then the motor is up on this. Yeah, you get that, unlock it, you get my feedback. This will be 3-phase below here. How you doing, man? Going hot. This is 3 hots and a crank. Between them, there's 3 hots, different phases, 3-phase powers. A lot of what you have in the plant, 3-phase, print industrial. Like Shimmer, everything they got is 3-phase power. And it maybe some of it might be 240, some of it might be 480. The 240 flow in this range, and the high will be 460, 480. So everything looks good. And when you hit the button, the motor should turn clockwise. So
I like it up here. So
yeah, right up here. When you hit the button, it should start. There you go. The motor's turning. So now let's go back and look at the rotation of the motor. If you hit the stop button, let's see what is it. That way it's very visible. Yes, going clockwise, exactly right. So let's say, for instance, that you might need it to go the other way, to rotate the other direction. What you do is on a three-phase motor, it's very simple. You pick any two of these legs out here, like leaving the starter, and you reverse any two of those. You just pick two and flip. And it's common to do 1 and 3, but it doesn't matter which two to do. So we're going to lock it out.
out of here at the bottom.
Yep, we're going to come down here to the bottom of the starter. And it can be done at that point, it can be done above or below, it can actually be done at the motor. You can actually come in here and you can reverse them in here, but it's best to do it wherever it's most convenient quickly. It's actually faster to do it here than to undo the wire nut. So we're going to let you lock it out. Put the lock back on it. And then we're going to let you test it to make sure it's dead. Put the probe in there like that so the bolts. You can go up here and check your incoming to make good and sure that it's dead. So you can go from each phase to ground to start. We go to ground and then go 1, 2, 3. Flip your meter around where you can see good and we can see. So you got a 0. Now go phase to phase, go from L1 to 2, 1 to 3, and then 2 to 3. Well, yeah. And then you want to go 2 to 3 now. Right. So that's called phase to phase. And phase to phase, it would be, in this case, you've got 208 coming in. It's not even 230, 240, it's 208 in this one. So leg to leg or phase to phase is 208 in those 3 combinations. And the leg to ground will be 120. You'll find that when we cut it back on. So you can go ahead and now pick any 2, reverse them, and you can we'll bring it out this way. It'll make it easier. Let's get to it.
And I'm going to switch 1 and 3.
That's most common, do 1 and 3. Those of you watching, you always make sure that the circuit's dead. You verify it with a meter. He's going to the easiest spot to get to flip 2 of those phases. And he did lock the power out. So lockout, tag out is mandatory. Hey, how you doing, Doc One? Lockout, tag out is something that can cause you to lose your life or lose your job, damage equipment. So we'll slide it back, get our camera position back on the motor shaft, and you should see it kick off and go counterclockwise this time. And so you might be wondering, why are we doing that? That's because some fans need to go clockwise and some fans want to go counterclockwise if they're a fan, an exhaust fan or an intake fan in the room. Some fans pull air in, some push air out of the room. Some pumps need to go clockwise, some pumps go counterclockwise. Conveyors, sometimes they go uphill, sometimes they go downhill. So it depends. You can have that shield down to do that, face shield, that arch. So with motors, there's a lot of reasons to why you might need to reverse that motor. based on what you're driving. So now you can bump the motor on and now cut it off. And as you see, it's going counterclockwise. So that's how you do it manually. If it's just a regular starter, you just flip any two of the legs that go to the motor. And that, you leave that on. We're going to run, let you just test over. Now, here's something that if it's critical that the motor goes the correct direction the first time and you don't want to just guess at it. If you got something like a pump that it would damage it if you run it backwards and you hook it up for the first time, then you use something called a phase rotation indicator. And this meter will actually tell you which way the motor is going to turn before you even start it. Okay. So you put these leads here on the power source coming in, or you can put them at the top of that starter. And they're labeled 1, 2, and 3. So you want to put these plugs in there. You'll need to stagger them like 1, 2, 3 because of the size of these shoulders. So what he's done is he's put those 3 leads in there, and you're missing, you need to look up here to see what you might be missing. Now, it's telling you that the shaft will go clockwise. You see that arrow? The shaft's going to go clockwise if you keep that same phase rotation all the way through. So let's follow it through. Take the leads off. If you keep the 1, 2, 3 sequence from that terminal strip all the way through the starter, and you keep that sequence from the bottom of the starter all the way to the motor goes clockwise. Now, initially you saw that the motor did go clockwise. Now, like right now, if we cut it on, if he checks the phase sequence at the bottom of the starter where we flipped it at, well, actually, you won't even see it there because look, you didn't flip it. You didn't flip it up here. You flipped it down here. So it's not going to be visible unless you go on this end. You actually have to go on this end of it to see it, and you're just going to be hard to see it at that point like that. Yeah, if you had done it up there, if you had done it at the top, it would show up at the bottom. But because the phase sequence is correct all the way to the bottom, and if you actually change your sequence on the motor end of it, you won't see it with that meter unless you actually go on the motor end to read that. So that's now if you go up here and put these in the wrong order on the strip, then you'll see it. It'll show you it'll be the opposite direction. You can change, instead of going 1, 2, 3 with the plugs, just change it in some other order, and the meter will tell you that if you go in that sequence to the motor, that the motor will go the other direction. You see that? And it told you it's going to go to the left counterclockwise. If you follow that sequence, that's basically what you did, but you change it on the bottom end, so it would show up at the motor end if you plugged it up in the wire nuts. Okay, now so you cut it back on. Now let's go over a couple of basic measurements and using the schematic. So now you're going to get your meter out and go to the motor leads and check from each phase to ground, leaving the starter. And then check phase to phase, leg to leg, 1 to 2, 1 to 3, and 2 to 3, where we lead going to the motor. So you use a regular meter for that, just not that one. You go on volts. Be careful about the purple button. The purple button is a whole button. If you press it, it's going to freeze the reading on the screen and it won't update. Okay? Okay, so yeah, your phase phase. And this position where we can see good, you hold the meter back there. You go. You got 211 when you go from phase 1 to 2, 210. 1 to 3 is 209. And then 2 to 3 would be, it's 212. It's in the range of 208. And it goes from each one of those to ground. Use the ground for up here. Right. Move the plug. It should be 120. It is, and then check all 3 legs. Yep. That's correct. Now you're going to check the amps. So you check voltage. Checking the amps, you go to A, and you're going to put the plug back in the back of the meter and use the port to pick it up to the port. It's a current pickup that you use to check amps with. You don't use the probes on this meter. Right, so you put each lead inside that magnetic pickup on the port. So it's 1.6 amps for the leg 1, leg 2, 1.8, and then 1.7 there. So that's pretty good. There's an amber alert. There's a child been abducted in San Francisco. There has been. There absolutely has been. Yep. Yep. I heard it on the radio, and that's what you're going to hear.
Amber Alert Church, NC Sampson County. Call 911 for information.
A little girl got abducted in Turkey. Right. So now, you check the voltage on each lead, and you check the phase ground, and the amps. Now, if you come over here and if you wonder, is that number of amps reasonable? You see right here, for voltage, you got the low is 230, the high is 460 range. So look right here, Brandon. See, for amps, there's 2 amp readings. There's a 2.8 and 1.4. At 230 on the low voltage, you should get somewhere in the range of 2.8 under full load if the motor's actually driving current. It's much less because it doesn't have a mechanical load that's driving. And also at a lower voltage, that's going to change the amps a little bit. But you're not exceeding that. The point is you're not exceeding it. You will have about 1.7 amps. Yeah. So you're within the nameplate. That's kind of how you know, or you're within what it should be. And then if you got issues with this overload relay tripping, this thing will trip if you draw too many amps. Inside of here, there's a dial. That dial determines how many amps it trips at. So this here is set. It can be set from 5.5 amps to 8 amps. And so that's the range of this one. They make them a different range. If you exceed the setting, it's going to trip out. It'll cause that normally close contact there to pop open. It will cause, if they get too hot in there with too much current, then these will cause that to pop open, and it cuts the neutral rate of the coil, and the whole thing will be getting down. So the way you pick your set point for this is you go to the motor, you get that amp setting right there, that 2.8, and you multiply it by 125%, by 1.25. You boost it up, and it gives you some extra amps there. So you take the 2.8 times 1.25, and you go there and set that. We'll be covering that in the book down the road. It just makes it in the book. And that's the correct way to set the overload. If you don't set it way too high or way too low, don't assume it's been set correct when you go up to it. Okay? And then another thing is, you can leave it run, but actually, yeah. Now, the thing that makes the starter pull in is the A1 and A2 terminals that are right here. Those two. When you hit the start button, you get power on A1 and A2. So go to A1 and A2 with your meter, and I want you to see that pull in when you hit the start button. So he's going to measure A1 and A2 the coil. That's what actually pulls it in and makes those three contacts close and the holding contact close on there. I'm doing this because pretty soon I'll be putting a plug in here for you. So there's no voltage there at this time. Now, if can you manage to hold them probes and hit the button? Can you manage to do that? Put one of the probes behind the meter. So now, now press the button. You see it, there you go. Right. It's a little bit low because the transformer, you're feeding in 208 into the transformer, and it's the transformer is actually designed for 220 to 240 on the incoming. And if you look over here on the side here, for incoming voltage of 240 on that transformer, you would get 110 coming out. And at 230, you get 115 out of it. At 240 coming in, you get 120. Well, we're feeding in less than 220, we're feeding 208, so you're getting 107 coming out. It's proportional. This thing steps it down exactly in half. So you get half of what's coming in. So anyway, that's your basics on doing your readings on the circuit. So your next step is going to be this. This is your lab sheet. Just get right here. So each time you do one, I'm going to sign off on it, and I'll record it in the Moodle, and then you get it back. Now your next is going to be, you're going to add lights. You're going to be your lights that you put on there. So it's the same thing. Can I go ahead and do the high voltage real quick too? It's not here.
Oh,
It's not here. It's not up here. It's a different power drop over there. The conveyor is.
Oh, okay.
It's just that conveyor.
I do need to do that sign.
I'm going to let you hold that, and I'm going to explain. So what he's adding now is he's going to add a green light in parallel with the cord. The green light has those two terminal markings on it, and you're going to wire it to the A1 and to the A2 or to the 95, the green light. The red light is the X2 on it, the neutral. It's going to hook with the 96. On the neutrals for the lights, they're going to be white wires, and on these, they can be black or red on the tops of the wires. Now, the red light, you want the green light on when the coil's on. You want the red light on when the green light is not on. So to make that happen is we take that red light and we come back and we use a normally closed contact. It's mounted on front of the starter. So if we move that, there's 21, 22 right here. Look closely at it. You see 21, 22. It says ELC for normally closed. See that? That's a normally closed contact, that one in the middle there, which means that when the starter is disengaged, those two contacts are touching each other, which makes a switch contact when the starter is actually de-energized. So you're going to run your power line, tap back up here for the fuse, and go to 21 on the front. And then 22 is going to run to the red light. And therefore, and it's also labeled M because the coil is broken. But when that coil is de-energized, this will be made. Okay? When the coil comes on, this will open. So this is always opposite from this. The holding contact that you have here is already wired. It goes in line with this. When that coil comes on, that closes. But that coil will make this one. When that coil comes on, it's going to make the top open. That coil is de-energized. This will be closed. So the holding and then this one is always going to be opposite. Always opposite. If that's closed, that'll be open. If this is open, that'll be closed. Normally open, normally closed, and they're both M and they're both controlled by this, and they're both of them side by side of here. That coil controls. So that's going to be your indicator for that red light. Got it? And then the job switch, we want it so that when you're to the right, to the left, if you're in run mode, when you hit this, it's going to run. When you're in jog mode, we want that to be a momentary. When you press it runs, you let go quit. We want it so that button can actually just bump it in jog mode. So the way that works is like this. one row. Okay? The way the job switch works is like this. You go in there to where originally you had a wire going from between stop and start going straight to 13. Originally, what you got right now is straight from here to here without that in there. You go in there, you remove 13, lift 13 off of here. You lift it off. And then you're going to run that same wire, pull it off of 13, and come out here, go to that switch. Leave that switch and go back to 13.
Okay.
Then this switch can actually connect 13 like original or get rid of it. So the way you create a job, you hold that right there. The way you create a job situation is you interrupt like we did right here. This switch, when it goes in the job, the contact goes down. It disconnects 13 so that this can't hold. So it basically takes power off of 13 so that you're stuck with a series circuit that's just a push button with no holding contact. So it takes power away from holding contact and you put your job up like this. If you go to run, that contact goes up, it restores contact there like normal. So if the job switch is nothing but you get your 13 hooked up or it hooks. You go ahead and do all of those. We'll let you lock it out. We'll put your board back up there. Somebody will come back and check. Okay? Yeah. And I'll hold on to this. That'll be my record if you've done that.
And will you sign off on those that I've done?
Yes. Yes. Okay. Hey, whoever's got a board to be checked.
And where's in the software and those. I don't know what I did about that.
That's okay. You're welcome. We're locked out. Yes, sir. And look, you take that loose, we're gonna roll your board over that way, and somebody else can roll on. Okay. We're gonna let you unwire this because that way they'll have to do it track. Each time, at least for the first few times, everybody needs to do this scratch. I think I need to roll back over and check single phase lab so we can keep cycling those through. If somebody has a board to check, he's moving his out. Whoever's got a board to check. And does somebody have the single phase pump check? Okay, I'm gonna come check it now. All right, so that's where I'm at now. Brandon's moving his out. You'll put it right here. How y'all doing? The face shield, that face shield from over, whoever's gonna get checked, who's getting checked now? You want, what, here? Yeah, right here. Okay.
Okay, I love those. One by one.
Yeah, everybody get your gloves on. Yeah, get some gloves on. This is gonna help us to protect from, spreading anything, not that anybody does have it, but it's gonna help some anyway. Every little bit of help. That's going down. Pretty good. Good. Incoming. Now, so this is the high voltage up there. I think did you go off of it? Yeah. On here, we're dealing with the high voltage on the 230 range. It's actually 208. This and it's just high voltage. If you make your incoming line, your 1 and 2, and I don't even have these labels here. But line 1, and it don't even matter which one you hook up how. But line 1, pick one of these, it's going to go to blue only. Line 2 would go to yellow and black only. And then your orange, red, and white, it says insulate, they just go to wire up. Yeah, they're going to wire up. They don't do these one line. So that's the high. Yeah. That same motor can run on low or high voltage. The same, just like over there. That same motor can go low or high.
If you want to do low here, you high over there.
No. This is high. This is the 208 hooked up here. This is the 200 volt line here.
Yeah, I'm on that one over there.
No, that's one. That's one. If you look at the plug, that's in here, it's a big plug. That plug over there is a little 120 volt plug.
So that should tell you it's in high volume.
And when you look at it, it's just a big plug. It's one of these big ones. And it'll tell you the voltage right here. But this one can go up to 250. It's not 250, but it's really 208. Don't come through it. But this is definitely not a 120 volt plug, And it's these motors, most of these motors like that are on farms or small motors in the industry, a lot of them are going to be what we call dual voltage. They can run on low high. And then the company doesn't have to stock so many motors that one motor can go in a lot of places.
So either one of these can go to the blue?
They can. Yeah. Yeah. And it won't even change the direction of the motor. The incoming wire is going to that motor. If you flip the power lines going in, that motor still goes clockwise. On a single phase. And when you go 3 phase, it changes. When you flip the incoming line, it'll make it go the other way.
Does this two go with it?
There's a 3 diagram up here. Yellow and black goes to the 2 other lines. Exactly.
Are you checking for the reverse too?
You'll have to do reverse on one of them. It doesn't matter which one. Doing the reverse is the same step. It's the same step. Whoever's watching, this is something that we looked at yesterday on the video. I'll just get you one little glance. Instead of explaining it all over again. He's going with the high voltage hookup there on the right, the high voltage, and everybody that has a lamp sheet. And that's the one he's doing right now with the blue, the incoming line, and then the other incoming line is yellow and black. And then the three in the middle are insulated with a wire nut. So that's what he's doing there. Check the roll real quick. Is Cameron here? I ain't seen Cameron.
He's walked in. I think he's over there. He's over there.
Yeah, okay. Nathan here, too. John was there before, but I don't see him here. He was out next. Roger Wilson here? Yeah, Roger. Yeah.
That's why you're protected, but I put it just right now.
Orange, red, white. Insulated, INS means insulated, it's just a wire nut, keeping them together, and yellow, black. That's, you see how loose that is? You have to strip it a little bit longer, so it don't grab out again. We just take those apart. But you can't run it with a loose connection, that'll end up coming loose in the cab head, it'll arc and it'll short out. So. Undo them. You're best off, instead of you doing all the twisting yourself, put the wires together and let the wire nut do the twisting. And then it'll grab better. It's going to get a better grip. Just make sure you put the wires end to end together, put them in the wire nut and let it do the twisting.
What color is it?
It's one of your, I have to look up the numbers. It's what machine processes is one of them for machine shop. That's a good class.
I think it needs somewhere.
Yeah, I'm not sure when they're going to offer. It's usually either a spring or usually a fall or a spring class. I've never seen them do this in the summertime, but they may have. You don't think that could. Barney would know that. He could tell you what they're going to be running. Right, you want them nice and high. Again, once you shove them in there like that, put that lid on there, you don't want something popping off and working out. They'll be calling you right there too. By the time you go, you get the sound when if we call you the machine. That's not fun. Okay, the plan is hooked up, so that's good. And so you've got your, where's it, the shield application? You're going to need the jacket on, electric gloves. Yeah. Yeah. I think the arc flame shield is over there. You got the shield over there? Yeah. Good, put your gloves on. If you're over 50 volts, you got to have them on. Thanks, bud. Appreciate your help with him. Helps me to get around quicker so we can cover more in just a little bit of time. This time goes by too quick, way too quick. Yeah. That's arc rated there, flame resistant. Yeah. Grab it. Right, you button that coat. Yeah. Yeah. If you don't button it, they can't protect you. That sweatshirt you got on probably would, if you got an arc on it, it probably would catch on fire. You know, not that would happen, but it could happen. Everybody needs glasses on. You got glasses? Yeah. Yep. Yep. There's a box of them over here on the table. Yeah. Ben, there's a box over here on the table. Yeah. Right there in the corner. Okay. Cut it off and go to the wheel. I got last round. So let's stand aside this way, let's put it on, and we get the camera on this end. Just a little bit of extra doing here to keep this thing on the Zoom. Everybody's not here, and I'm trying to make it where people can see what's going on. So, turn it on. Turn it off. Notice the rotation. See, it's going clockwise. See it? Now, so to make it go counterclockwise, that you might have a fan that's an intake fan on one, you might have an exhaust fan. So, on farm or wherever you're at, or in industry, you may have to make that motor go the other way. So we're gonna let you flip it. So look, you're gonna let you lock it out. If you disconnect the main power line and I'll put that lock out back on the plug. Now it tells you right on the motor plate. What does it say do down here to reverse it? Let you read that out loud. You're going to change the black and red this within the motor. Now, not the incoming lines, but what's within the motor. What you end up with is this. You're changing the start line. On this one, the black and red is the outside leads, and you're flipping the start line without flipping the main run line. Okay? So, and that has to do with that start capacitor and that centrifugal switch. When it starts out, that switch is closed, and that start capacitor gives the start line a boost. And when you flip the black and the red line, leads, it changes polarity of that winding and this. Exactly, yeah. Now, so you disconnected it. I want you to verify that the voltage is dead. So before you unhook it, we're going to make sure that it is dead, open that up. And then internally, you'll go from leg to leg and then make sure it's zero and go each leg to ground and make sure it's zero. You're on the volts, okay? Zero there. Well, instead of checking top and bottom, look, you check across the legs coming in, go L1 and L2. Zero, exactly. Now check from each one of them to ground. Right there. That exactly. Zero. Now you're fine. Now, the step to have done before that would be to make sure that the meter's good on a power source that we know is hot. So how do we find that out? To check the meter, stick it in that hot and that neutral right there and make sure the meter's before you go test any circuit. Got 121. So you know the meter's good. The meter's not bad. So that's the OSHA recommendation, checking on a non-power source and then check what's gonna be dead. You know, and then you know that meter's okay. So it's dead, it's locked out, and that will let you do the reversal now. I taught this last night online to a Murphy Family Ventures group. Got some guys on Hawthorne, they're taking a Zoom class from me at night, on Monday nights. And this is the exact same thing we're doing right now. I showed them last night on the camera.
Would each fan, like a hog farm, have one of these?
Yep, each one of them will have a motor. Each one will have a motor. And probably they'll be belt drive, be belt driven like this pump over here. Fully. And some fans pull in and some fans pull out. Just depends on which one you're on. And some pumps go clockwise, some pumps go counterclockwise. So, so your in the middle of it, that red's coming out, it'll be orange, black, and white in the middle. And then on the bottom, it'll be yellow and red. It'll be yellow and red exactly. Yes. And what you're doing is you're flipping the start winding that contains that capacitor. You're not only changing the capacitor, but you're changing the entire start circuit that includes a winding and a capacitor. And without changing the polarity of the main windings, you're making that be opposite from the main windings that's on the inside. So you've got yellow and red this time for one line. That's correct. And then your orange, black, white. That's correct. Now the motor's going to go counterclockwise. So that's this on. Some people think they can just go up here and take these two incoming lines here, the power lines, and flip them. That motor will still go the same direction it did in the beginning. It won't change it unless you break loose the start winding and run winding and flip that start winding. Well, that's this drawing, you know, it shows that. Yeah. Mm-hmm. Make sure your face shield is down. Right. And then when you kick it off, you'll see it go. Mm-hmm. Yep. Okay, now cut it off and you'll see it go this way. See it going the other way. So that would be if your fan wanted, if you had to have whatever you're driving going the opposite direction, that's what you would do. Make sense? Now leave it plugged in, let it run, but once you do some measurements in here with a meter. Don't force it. There's a little L tab, that's the ground. Put it back on. Let's open this up. Let's get up. We got to do the little override. Let's get the big line. There's an interlock there. We have to do that to get into a lot of run. If you need to, if there's a lot of cases that you will. Whatever the interlock is, you've got to override it to get into it. So this time you'll check the two incoming legs, leg to leg, and it should be around 208. I'm gonna get on this side. So he's checking the two incoming legs, it's gonna be around 208. And now check each one of those ground that should be 120. 122. That's good. Now check it leaving the fuses. Go leg to leg on the fuses. Yeah, you're going to check the outgoing two lines. Well, you can go to the ground on each one of them. Should be 120. And now check leg to leg on the fuse. Yeah, that's it. That's correct. You get about 212. Yeah, that's good. So that's how you can diagnose it going through your disconnect, and now you're gonna check the amps. So put that plug in the back, put both of them behind the meter, and go to A for amps. And you're gonna use the fork to check the amps, not the plug. So you can go ahead and put, the best thing is to get them plugged up. Yeah, exactly. What was that, 4.2? That's 4.2 amps. You got to get it all the way up in there where the lines are to get. Best thing is to come down here and pull it where it's leaving. You got 4.1. You got to get that just one on, just one wire. You get 4.2, about roughly 4 amps per leg. And so if you wonder, is that okay or not? So you close that up, cut that off. You go up to the nameplate. So the nameplate is telling you see where it says amps. If you're running on 115 volt, the amps under full load would be 13 amps. If you're running 230 volt, the amps would be half of that, be 6.5. We're running at 208, not 230, and we don't have any mechanical load that we're driving. If you have this hooked up to a pump or to a fan and you're driving a mechanical load, you're going to get somewhere in the range of 6.5 amps of withdrawal when this is actually pushing something. If it's for freewheeling, the amp draw is going to be less, but my point is, when you check the amps that way, make sure that it does not exceed what the nameplate says. If it does, there's something wrong. It either means that you mechanically, you might have that your pump that you're driving might have bad bearings in it. It may be in a bind. Your fan may be in a bind. But it's something mechanically that this is driving could be bad. If it's drawing too many amps, if it's drawing more than the nameplate, or the bearings in the motor could be going bad. So when they begin to go bad and they start to drag and squeal, then it's going to be drawing too many amps. Or the windings on the inside can start shorting out. When they do, it's going to draw too many amps. So we'll get into that stuff later, but basically, for whatever voltage you're running at, low or high, you go up under it, and it's going to be a correlating amp rating that you should be no more than that. When it's at top speed. Now start up, it starts up higher. You can see that the end rush, it'll be higher like when you start it up. You can plug it back in one more time. Go ahead and cut it off. Actually, cut it back off. Put the amp plug on one of them and cut it on while you got the amp plug on. You'll see an end rush. You'll see the amp spike up high and then it'll come back down. Only on one? Or on one leg, yeah. The amps. You're going to go to the fork again. When you're checking amps, you're using that fork to check it. When it's a magnetic pickup, you don't check it with the plug. Exactly. You'll see it. You'll see it. You see it go up. It went up. How high did you see it go? About 15. It's around 15 on startup. See it jump up. About 13 on startup. And that was with no pump. It was not driving mechanical load. You cut it off. Now when you do that on this one, where it's actually got a pulley on it, it's got a shield. It goes up to about 38 amps on startup. And then when it gets up to top speed, it levels on down to about 7. So when you put a mechanical load on it, that end rush is going to be much higher for a little longer time. And it'll settle on back. So anyway, so that's good. Any questions on what you just did? Okay, good. So let me sign your paper. And we're going to let you walk this thing out. Yes, sir. We will.
I never got a check off the paper either.
Okay, let me give you a paper. I've got them right here. You got to keep up with. All 4 slots, you give the name that you about how 4 work.
Commercial code.
This is single pay high. We don't have to say those two are two on that sheet.
Yeah, it is. You know.
Got life state, you know.
Because that, something.
That was okay.
Squat.
There was that. It's heavy. Probably less me, yeah. Maybe residents on that, yeah. What?
You can put elections in your program, you probably take that if you want to put your check, take one.
I'm gonna do mine tomorrow. I'm gonna do that second class on mine.
Are you about to buy one today?
Oh,
Definitely, that company's smaller.
You're down on the right.
I got one.
Yeah.
See my logo.
Yeah.
I want you to do that.
Yeah. Go to that office.
Camera, what's the money, see what we're doing. We'll talk about what we're going to check in the meter. So it's convenient to put one in close in there, so you can hold the meter like this, good steady, and just use two hands. So go to the volts, check volts of this one. And the points that we're going to be checking is the incoming power comes in here from the wall. You notice that black wire right there, it goes to the switch right here. That terminal right there. So it comes in here hot, stays hot here, and then it leaves the switch. The switch is actually those two right there, split here. So this terminal is here, and then the outgoing terminal is here, and it goes into the overload, thermal overload that's efficient with the tank. That's your thermal overload. It enters it here, and it leaves it here, and then it goes out in the motor. So it leaves here, it goes out that way. The neutral, it goes straight to the motor. So look behind here, you see a white wire behind this. And both of the incoming and the outgoing white wires are lined up. They're continuous. The ground wires, both of them meet on that screw. And so the ground is continuous, okay? Yeah, there's two, yeah. The ground, the green wire, there's two green wires on the under that screw there.
Is that the black from? Is that how you get power to this?
To the motor, yes. Yeah, that black one leaves and it goes out to the motor. It comes in here like this. That's the one that leaves the overload and it goes to the motor. You're leaving the overload here, goes to the conduit. That's the main black wire. That leaves the switch. The neutral, it comes out of here. It's the one that goes straight through. The incoming, the outgoing white wire line up, and it ends up through here. The green one is the one where they plug everything on the screw. It's continuous through here. And it goes through. You see where that ground wire goes to the frame of it? That ground wire is both the middle part. Keep the motor ground. So I want you to come out here with the meter. When I plug this in, I want you to go with that meter and touch here and touch ground at the same time. So put the red probe there, the black probe down there. And then I want you to move, keep the black probe on ground and move that red one from here and put it here. You'll see that it won't be on here, but it will be here. Because the switch ain't on yet. So yeah, bring your face shield down. Now that 1.4, we got that. That's right. You can turn the hole. Everybody ready? Okay, so now do your first voltmeter test. Put the probe back in there like that. Put one up behind it. Put it in from the top. Exactly. And put one of your probes down here. You don't want to cross your hands over, so just, yeah, reverse your hands. Actually, you can use that to check off, it's fine. The meter don't care on AC. Put the other plug on ground. You get the 121, right? But what you're doing, you're checking here. It stays hot. Now, what about here? So put one probe there, and then put your other probe here. That's where it's leaving the switch. That's not on now. You see that? It ain't on. Now watch. It's getting ready. Ready? Leave them on there. That switch is open. It's getting ready to close. Now you ready? Here we go. 1, 2, 3. See it? You got it now, right? Now, go another step. Go from where it leaves the switch going into the overload and check it leaving the overload. Right there. Where it leaves. And that's where it goes to the motor. And you know that the overload's good, the switch is good, and there's nothing wrong in here, right? And that's where it goes out. That's where it comes into the motor over here. Now cut it back off again. Now I want you to see something called inrush current. The current that motor draws it amps by putting it around that wire or the support. Not the plug. The fourth one here, because on amps, you can do the same thing as that plant. The plant goes all the way around, the fourth just kind of goes in like that. Just slow down a little bit more. And if your amp, the amp will be, if you're running a 115 volt and that line down, the amp should be 8.6. If you're running on 230 volts on the high voltage, like over there, it would draw half that on the amp. The amp goes out of the amp, goes to the amp that it wants to draw, it's trying to make amp gas. You know what I'm saying? If you double the voltage, then the amp goes down half well. You're running over here, so it's going to be somewhere in the range of 8.6. If the belt was hooked up, we could drive it home. And there's no load on it right now, other than just that itself. If we start doing it, you're going to see the amps go up super high around 38 amps instead of around here. It'll go high just for a few seconds and come right back down. That's the inrush it takes to get the cooling going. Even though it's not a big standstill, if you cut switch on it, watch the high stoke. 35 amps, then it comes out 7.3. That 35 was the inrush. That was the inrush current. So we talked about that in chapter 1. That's something that has to be, you cut it off now. The overload heater, that overload heater in there, that 4 looking tank, that time delay. So it allows for them to trip. If it stayed that high, it would trip out like a breaker. It would trip out quick. Very fast. That inrush would make the trip. If it was a regular breaker, it would trip really fast. So it has what they call a time delay to it. Now we're going to let you lock it out and then do a reversal. You want to weigh it up here? Do that. That means to slow all the way down. Right now, it's going to generate the voltage coming out of it. You'll just get the tangle. The windings in that motor right now. Those windings right there are actually not it's freewheeling. It's going to be generating some voltage coming out there on this line.
So to get it to reverse, I need to
Get back to the paper. We're shifting you down here to the reverse the black and the red. Not the incoming wire, but the internal wire. What it boils down to is this. You're gonna take that black one out of that bone and take that red one out of that bone, put that red up here, and that black one go down there. It's gonna be red, white, yellow, and then blue on black.
Red, right there, and black.
You're gonna go for that. Little diamond part there. Okay. You go ahead and do that. And
Take my gloves off and do it.
Yeah, you got that glove on. Yep. Brandon, if you want
You fix it every day. So we have
I got it.
Yeah, these classes are short, man. It's, used to.
It usually-
4-hour classes.
This guy's right here goes by quick as a hole.
It does, it does.
I don't know what it is.
And it used to be a 4-hour class, 2 days a week, 4 hours a day. Now they cut it back to where it's 3. They cut an hour. They've actually cut 2 hours out a week on face-to-face hours, and they put it in the Moodle work. So it is, I'm having to put all your worksheets in Moodle, and you do those outside class. Used to, people were doing worksheets while they were doing lab. They would be doing worksheets on the way from me. You can still do that at Moodle. You can still do it.
Wow, it's taking over.
Mhm.
The internet's taking over.
Well, basically, with the COVID, they want to cut down on exchanging papers. They want to cut down on that as much as they can. So if all your book assignments are done online, it's going to be less risk of staff.
I just texted you.
So you're at Shimmer working all this?
I am, I couldn't go back to the COVID. But, yeah, I'll go back to this Thursday.
Right.
I'm ready to get back. It's been a while. Like 2 weeks, 3 weeks.
So what are you doing?
Just same thing, good. I've been working on the budgets down there and running on marketing, building control and stuff.
That's good. Stick with it. It's a good place to be, man. It's the only place I know of in this county where you do just electrical work.
Right.
In a plant. The only place I know of. Everywhere else, you're gonna do that plus mechanical and hydraulic, a little bit of everything.
You know, each section, each part.
Right. I got several graduates that's out there, Daniel Smith and Rodrigo, they're all over there.
Well, I like reading.
It's cool. It's cool, man. Good guy. All right, so you got your red, white, yellow. One line white. So it's ready now to go this way. Okay, see you later. Y'all just kind of bear with me on the wait time and when you get to you, just be ready. And if you're waiting, if you need to go lab too, I can do something different. I've got a hand got board over here on the wall. I can put up something else different for you too. Just let me know if you actually need something too. At least 4 days a week, you're short for 4 days. I need to be getting a swim class on, taking the commercial line. I'm having these quarantine at home without teaching. I'm swim on there. So that the class is free. All right, good to see you later. Bill, what's planning, Bill said, hey, okay, now watch. This time we're going that way, so we'll push the switch on the front, right back off and watch the foot. See it? It's going this way now. So whether it's a pump that needs to go that direction, or fan, or conveyor, that's what makes it go the other way. But it's not changing the incoming wire, but it's changing the start wire. The outer wires will be the black and the red. You're changing those out here, the bundle, without changing the orientation of your main wire. Well, not necessarily. Don't ever assume it. Go whatever it says on the main wire. You got to go by whatever the brand motor needs. You got to read right on that place to make the change. So in here, the black and red is actually a J10 and a T8. It's a 10 and an 8 wire number. On this particular brand here, it's 8.5. It's 8.5, not 18. It's a different brand. So the number can change, the color can change. So, you know, but that's it. Yep, good job. Somebody's going to sign one. This yours right here. I got you now, got a reverse. So you've done reverse one and do reverse on that. It's the same thing. It's the same, you flip the same two wires. It's just the phone. You same two wires reverse. Keep up with this, and when all 4 check off, you turn it in and I'll put it in.
It's actually something handy for me because I've been around with people that don't know how to read cursive. And they want me to learn to read something. That's in cursive.
Okay, we've been moving around a lot, but that's the nature of our labs. And I thank you for watching, whoever's watching. We're going to end it. Hope you can be here tomorrow and have a blessed day.